All right. So today we're gonna finally be tackling queries and join queries in SQL. Now that we've looked at schema design, we've dug pretty deep into relationships. We're gonna see there's all sorts of awesome querying that we can do once we've created this really nice data schema with lots of integrity and all that good stuff. Um, this is useful for reporting, but also we're going to see for a lot of real world programming tasks. Again, SQL is really this Swiss Army knife that's stuck around for a long time. We're going to see there's some good concepts here. Joins are especially powerful. We're also going to see some tactics to help sort of familiarize yourself with a new database and get up to speed with it. And the database we're going to be working with is here in this example directory. It's a car shop database, and I actually have it over here as well. But let's take a look at the SQL quickly. And my apologies, let me tile this. So actually, let's look at our CSV. And that's really the first thing you want to do when you look at a new data set is look at the data itself. I want to look to see if there are column headers. I want to look at the data. I want to see if data is case sensitive. I want to see if I have to worry about special characters. Excuse me. Um, I want to see if there's anything a little counterintuitive, like this looks like a driver ID column, right? Um, I want to get a sense for the different kinds of valid values for my data. And raise your hand if you worked on the 64 slices problem and encountered some unexpected data challenges with those CSV files.
Especially at the very end with the multiple toppings.
Yes, that was very much by design. Um, I threw in a CSV file of pizza toppings, and part of what you all have to do is build a database, record pizza orders, and the challenge of how do you relate pizza toppings to a pizza order, I deliberately left open, and there's more than one way to tackle it. I think there's also some data in there that may have had like deliberate issues, if I recall. Um, so as we look through this car data, and this is exceptionally well organized data, frankly, real world data is incredibly messy. You would be shocked. It is really normal for real world data to have all sorts of inconsistencies and problems and errors. Um, I can promise that any of the data inconsistencies you've seen in our CSV files and the various assignments pale in comparison to reality. So as we look through this, this helps me just get a sense of things, right? Phone numbers. Does the phone number have a dash? Does the phone number have to exist? There's a lot that I can infer by seeing that phone numbers is essentially an optional field here, right? Because often in the real world, we might not have someone to write requirements for us, or our stakeholder might be someone who's non-technical and they don't know how to think about these things. Again, we see employee information, middle initial. Not every middle initial exists, um, and so on and so forth. Now, for this problem, we've gone ahead and we've written the SQL to build a data model. And we're going to look through it briefly and then create the database. And then I'll show you how to import an SQL file into Draw SQL. And then we'll dive into queries. So we can see here we have a departments table for different areas of the car repair company. And departments have a department name that has to be unique and not null. We can see here for employees, they have a salary. We see here there's a check and a not null for salary. We see here first name and last name are not null, but middle initial is null is okay, making this essentially optional. Department ID is optional. And then we see a foreign key reference here. So that department ID identifies the department that the employee works in. Um, for services, we see there's a varchar. We see some additional checks. As you can tell, it, I think it's definitely worth reading through this in full later to just see a number of good checks as a sort of like reference example. We see here for our driver, only name is required. We see here a car. Um, we see that there's a check on the year. It's got to be past the year 1900. And there's a foreign key relationship to a driver. So a car has to belong to a driver, or rather, a car can belong to a driver. We have a license plate, and then we have the kind of service performed on the car, right? And so here, a service is connected to the name of the service and the car ID. So does the fact that this car service table have two foreign keys bring to mind any of the relationships that we were talking about yesterday? There's a name for this
Many
kind
to
of
many
table. Yeah, and why
junction
many
table.
to many?
Uh, because you're referencing service ID from a
Hmm.
different table and you're referencing car ID from a different table.
Yeah, and I think you were saying this is what kind of table is this?
Junction table?
Yeah, junction table or join table. You'll hear both of those terms, I think. Um, so the job of this table is to be the linker between a car and a service so that I might have my car get serviced and get the oil changed and the brake pads replaced, right? A car can have many services. A service can be done to many different cars. So, so far so good. I'm going to go ahead and I'm going to create a database and we'll just call it car shop. And actually, I already have one. So let's go ahead and drop it. And now let's create it. And now I'm going to connect to it. And I've I'm making sure that I'm running pSQL from the same directory as my SQL file and where the data is, so that relative pathing will be correct. And I'm going to run the car shop SQL file and execute it, which will create all these tables and use this copy
Are,
command to load all the CSV data in.
are you, never mind.
Oh, what's up?
Were you connected to the right database or were you still connected to Atom CEE?
Uh, I totally forgot to connect to the car shop database. You are totally correct. Thank you, Nick. Um, Good to see though. This is a common error. If I can remember, is it DD? Does anyone know how to get the current database name in pSQL?
You gotta change into it, right?
Well, you
See?
can connect to a database, but there's got to be a way to get,
Oh, L. I think L.
let's see. So L lists all the
Oh, like the
databases.
equivalent of PWD, the current.
Do they have a version of PWD?
No, I'm it's
No.
just the analog to it inside pSQL.
Right. Indeed. And I don't know this either. And so as you all may have noticed, I went ahead and just Googled it. And lo and behold, the first search result looks like it gives me exactly what I want. Um,
That's from 11 years ago, man. That's
it is. Uh, the beauty of Postgres is that it doesn't change nearly as much as JavaScript. JavaScript is changing all the time, and you absolutely need to pay attention to how old something is. It's important but less relevant for Postgres and to a degree for Python. So there's in fact two ways to do it. Postgres has a function, current database. So if I do select current database, and let's run it again. I didn't have a closing parentheses there. Oh, I see the PWD is sneaking in because the up arrow does not quite behave the way I want it to, or I'm confused by it. So this is one way to do it. So this is actually kind of cool to see because I can put this in an SQL query, and that's a Postgres function that we're using in SQL. And then pSQL has a con info command that tells us database name, username, port name, which is honestly way more useful. Right, so the answer here is the connection info or con info command. And now I do indeed want to connect to the car shop database, like you were saying, Nick. And now I want to run my SQL. And now if I do DT, I should see my different tables. It never hurts to make sure that everything looks correct. What I like to do is I just spot check a couple. I want to look at both the schema, and I also want to make sure that the CSV files were correctly imported. We would probably see an error message if they weren't, but remember SQL continues executing. So let's just spot check a couple. Select star from services, and we see some services. Select star from driver. We see some drivers. We look good to go. Okay, so far so good. What if I want to import my data schema into draw SQL? So I don't want to build this out by scratch. I have an SQL file. Draw SQL has a very useful import command where you can import from, they call it a data definition library or SQL file. So we have two options here. I can import this car shop SQL file, and that will work just fine. I can also dump the data schema from Postgres. And I can do this with a command called pgdump. And this can be useful if you need to back up a data schema at some point, and it's just good to see it. So let's try pgdump car shop, and let's use the sort of arrow key to indicate that the output of this command, and let me go ahead, and I apologize, I actually need to be on the command line to do this. So pgdump is a command line command that is installed when we install Postgres. So I'm not in pSQL right now. The same way that createDB is a command line command that gets installed when we install Postgres, as is dropDB. So if I just basically Postgres has given us some nice utility functions for the command from the command line. So I want to pgdump car shop database, and let's put that into car shop schema dot SQL. And before I forget, let me put this in our README too. Oh, and in fact, we already have it, even better. So let's look at this schema file and see what it looks like. This is sometimes called a DDL file. As we can see though, this is just plain old SQL. There's a lot of SQL database settings here for Postgres, character encoding, a timeout setting, some other stuff we don't need to worry about, like row security. I would just leave this all as is. We want to leave all these messages so that someone else looking at this knows that this is a dump file, that this was auto-generated by Postgres. We can see here there's some namespacing that we don't have to think about with the database when we're working with tables and things, because everything on a database sort of by default happens in the public schema. Um, we see here things like creating the sequence for the auto incrementing car ID that under the hood Postgres is doing for us when we do, if I go up to let's find the car here. Here we go. So on line 50 here, we see that what I said was ID serial primary key. Under the hood, what Postgres does is it makes ID a not null integer, and then it creates a sequence um, that it uses a naming convention for and is going to associate with that ID. And so there's a lot of extra stuff here. So this is cool to see because this is like a complete representation of our entire database, and we get to peek under the hood a bit. So I think this can be really good. I would encourage you guys to maybe do a dump of one of your databases and walk through it. But now that we have this file, let's focus on what we want to do with it. What I want to do at the moment is I want to import it into Draw SQL. And let me go ahead and navigate to where I've put it. So just bear with me here as we navigate through everything. And now we can import that DDL file. Draw SQL will probably ignore the sequences and stuff. We'll give it a minute. Import complete. There's some warnings here. We don't really have to worry about them. It does encourage us to review the relationships that it inferred from foreign keys, which is good advice. As we know, programs aren't perfect. I don't need to do any multi-selection. So, we can maybe double check that the relationships are bang on, but we see here something pretty decent. And we see our database of employees, departments, services, cars, plates. Um, and let's rearrange this just a little bit. And I'm going to move these up here just so everything is sort of a bit more organized. But now we can really see how this car service table is a join table that connects car to services, right? And in fact, let's go ahead and let's put this over here. Yeah, I'm not going to worry too much about the diagram. I'll probably get lost in the sauce. But again, this is what enables the many-to-many relationship so that a service can be applied to many different cars, and a car can have many different services. So I just want to pause and check in and see what questions folks have or stuff that people might be curious about, whether it's about the import process or the data dump or anything else, as we sort of have been reviewing and warming up and seeing how to explore this database. Cool. We feeling pretty good? Awesome. Yeah, the ability to just import a whole SQL file is great. The ability to do a dump like this also is amazing. I think the dump includes the data. Don't quote me on that. Let's do a quick search for insert. Yeah. So Postgres is doing something fancy here. It looks like with this copy from standard in command stuff. I'm not sure exactly what it's doing. Maybe it's like printed the data out from the database and then I see. It's putting this in as standard input and running a copy command. So it's sort of manually feeding it in. But what we have here is we see that the data dump also has the data in the database. So this is actually an effective backup tool, though there are probably better ways to improve upon this. But as a quick and simple way to back up your whole database and its data, the pg dump command is quite useful. Okay, awesome. Let's do a little more exploration of our database, and talk about some tools we can use when exploring databases. And I'm going to pull up pSQL here and make it quite big. So it's really important to have a process for familiarizing yourself with new data, both the CSV files and the database. These things will also help you on technical interviews because the exact kind of things you want to look for when familiarizing yourself with a bunch of data you need to create a data schema for or an existing database are the exact same kind of gotchas that show up in technical interviews, right? If you guys think about all those leak code problems and the kind of gotchas you see with string manipulation problems or stuff like that, very similar to what you want to look for when exploring a database. So one thing that you can do, which is pretty awesome, is you can add comments into the data model itself. So I could add a comment on the public schema. And let me do it again because I think I have some bad parentheses and issues here. So let's do this again. And let's actually just comment on the table and let's comment on the employees table. Now, getting the comments is a little trickier. There's a couple ways to do this. I could use, if I do D employees, it does not show up, but I believe if I do D plus employees, no, I apologize. It's not showing up then either. Um, the other way to do it is, as we're showing here, though this is a little awkward. And
You're closing semicolon.
oh, thank you so much. There we go. So this is a little weird, but this is how Postgres is storing a comment. Carlos, yes, sir.
Just out of curiosity, it wouldn't come up if you do the \L to list all the different tables.
So backslash DT. I think it should, I'm actually doing a sort of a Google search on the side here, and it's saying that, okay. So now we see it here under describe table with the plus symbol, and we see this comment sort of hiding here. And if we do /gt plus, so now so the plus symbol is how in the P-SQL we can see a richer description with comments. I'll be honest, I feel like this is a bit less useful. It seems like it'd be nice to have the comments up front, but maybe if I'm doing this all day long and I'm like a database admin, I want that extra level of control. But we can see here how I can add comments to tables and other parts of my database. That said, it's really going to be as useful as that is. I think commenting of the code is clearly the first priority. These other sort of good practices we've covered, doing some simple select queries to get data, looking at the foreign key relationships, building a data model. I do want to point out this explain analyze command, which can be useful to see what a query is doing. And let me get a little more screen real estate here. So I might have a query select first name from employees. If I add that command explain analyze to the front of my query, what I in fact see here is a deeper description of how Postgres actually executes that query, which is called a query plan. And we see here, there's not a lot happening here, but we see how long it takes to sort of construct the query plan and then to execute it. And as we start to build more complex queries later on in the lesson, we'll come back to explain analyze. So I just wanted to kind of walk through some of these best practices we put together. I think this is a good guide to go back to, especially maybe when preparing for interviews after graduation. And I just want to see if folks have any questions before we move on to constructing queries. Okay, cool. So for constructing queries, I'm going to have this up on the side so that you guys can see the queries. Again, I would encourage you not to worry about coding along. I know some of you are, but this way also when you review the video, you can have sort of both together. And before we dive into query, let's just again look at this diagram of our database. Sorry, this thing is so sensitive. We have a car shop and employees that belong to a department. And department doesn't really have many other relationships, but a department can have many employees. An employee has to belong to a department. Cars come into the shop to be serviced. Cars have a license plate, and it's possible for a car to have multiple plates over the course of its lifetime. Each plate is going to only belong to one car, though. A driver can have multiple cars. So I might have 2 or 3 or 5 cars. Got my winter beater car and my nice summer car. In our model, a car can only have one driver in terms of bringing them into the shop. And then once I've brought a car into the shop, again, I apologize about this. I have to click drag, the natural mouse motion zooms, and that always gets me. Once I bring a car into the shop, it can be serviced. There's a number of different services, but the way that I record a service is with the car service table that identifies the car and the service that happened. And this is enabling a many-to-many relationship between services and cars through its function as a join table. And I just want to see if folks have any questions on our data model before we start building queries. All right, let's start doing some querying. And as always, the Postgres docs are quite good here. I'm going to go ahead and I'm going to make a new file. And I'm just going to call it queries.sql. And this is where we'll do our work. So there's a number of great math operators we can use for our query. And the way to build queries, by the way, whether it's simple or complex, start with the simplest version of the query, run it, make sure I don't have any typos, that I didn't forget my semicolon, that I didn't do anything silly. Now let's use a where clause to filter these result rows, right? And you can think of this almost as a temporary table that's been created, and we're now going to filter it. And we're going to say that I want cars where the year is greater than 2020. And now we see there's only 3 cars where the year is greater than 2020. And now let's actually use explain analyze this on this real quick. So I am going to just copy and paste this in. We're going to just do it this way. I apologize. Explain, analyze, select star from car, where, year. And by the way, you don't need to uppercase stuff. I actually, all this stuff that's in uppercase, I usually type it lowercase when I'm doing queries. But for learning purposes, it's good because it distinguishes it, and it's a good habit because it is the convention. When you're writing SQL, you absolutely should uppercase stuff to make it more readable for other programmers. And here we see the query plan constructed. We see it's doing some sort of scan on the car. And then we see here a filter operation. And in fact, explain, analyze will tell us the rows removed by the filter. It tells us how long it took to plan the query. And it actually took longer to plan the query than it did to execute it. And in fact, if we just use explain, we see a query plan that has not actually been executed. So this can be really, really useful if you want to maybe see what a query is going to do before running it, or if you need to see more detail for some reason. And similarly, if we just have analyze, we'll just see the information about the query performance. And actually, I apologize. It looks like Postgres does not like analyze happening on its own. So I take that back. So let's run another select statement where instead of looking at the year, we want to find all the cars where the price is exactly $29.99. And it looks, I apologize, I have a typo here because this shouldn't be car, this should be service. I was looking at the wrong table. And this should probably be services. And there we go. And it's just the oil change that is $29.99. And there's a couple other aggregate values here or mathematical things. So let's take a look at those and then we'll move on to see a couple things a little more interesting. We have greater than or equal to, which is a bit more useful when looking at price. Maybe you want to find everything where the price is greater than 50 bucks. And finally, we have this really useful function, count. And this is going to do something really interesting. It's sort of an aggregate function. And let me go ahead and just comment these out. And it would help if I save my file. And I called this an aggregate function because it has run a query to probably get all the rows, but then we're counting all the result rows and it's just returning 10. And in fact, if here I do explain, analyze, select, count, star from cart, we see here there's this aggregate function. It's doing a sequence scan, and then it's counting the number of rows. If let's get rid of explain analyze, and instead let's do select count from car where year is greater than 2020. And we see there's only 3. And let me go ahead and copy this in because we're going to make a modification to this. So let me put this in our SQL file. Let's use the as clause to come up with an alias or variable name for this count. Because maybe if I'm generating a report or I have a lot of different counts, it might be useful to have it be named something else. And I do apologize. I think I put the ads in the wrong spot here. Let's try as total cars. And there we go. And so this gets useful as our queries get more complex. I could also do a count on a particular property. This would matter maybe if some, if there wasn't consistent data in each row, right? But often the star just means look at the whole row. And so if we want to count the number of result rows, this is often how you'll see it. And I just want to pause and see if folks have any questions thus far. Cool. So these aggregate functions start to get really interesting. As you can see with some, we can start to do more interesting things. I could add up the cost of all the services to see if someone bought absolutely everything, how much it would cost. With our employees table, I can add up all of the salaries to do the same thing. Um, and then there's also some useful functions like average, right? If I want to get the average employee salary. And let's take a look at our employees table. And we have salary, we have first name, we have last name, we have department. Um, let's say I want to find, let's look at the cars actually, because there's a little more data in the cars. And let's say I wanted to find maybe the different amounts of cars with each color. I might try something like this. Oh, well, let's that will come back to later because that one involves a little bit of grouping. Let's say instead, just to kind of keep this simple, let's say I want to find the average year of all the cars. So I think this will do it. Let's run the query and check. Let's make this a little more interesting. Let's say instead of just the average year, I wanted to find maybe the average year of all the blue cars, just to use an example. If we had multiple makes here, I would use that as an example, but and let me make sure. I've made a mistake.
Yeah, you didn't capitalize blue.
Yep. So let's use the lower function that we saw yesterday to modify my query, and I think that should do it. And now we have the average year for the blue cars. And if I could even use let's just stick explain analyze in front. I should see, I think there's two blue cars. Rows removed by filter, 8. And there's 10 cars in total and two blue cars just sort of manually checking. So that looks about right. We've already seen the where clause a lot. Um, I do want to point out this like operator, which is extremely useful because this is where we can start to manipulate text more easily. Let me just comment these out and let's build this query that we see here, and then we'll break down like a bit. And let's put this here. So like takes in a string, but I can use special characters like percent that indicate that on any side of break, we can have any text that we want. And just to sort of warm us up, let's do select star from service. And it should be services. So I see here, I would expect this query to return break inspection. And indeed I do. If I was instead searching for inspection, we should see that show up as well. Note that if I get rid of this percent sign here in the beginning, excuse me. Let's see what happens when we run this query again. And it returns nothing because now we're looking for something that starts with inspection and then has anything else after it with the percent sign. But if I have a percent at the end and I run inspection, it shows up because we have inspection at the end of the string. And in fact, let's look up like, and Postgres has something called iLike, which is also extremely useful. And let's look these up in their docs briefly because of how useful they are. So there's something similar called similar to, but what we really are interested in is like. As it says here, it returns true if the string matches a pattern. We can also do not like. So if I wanted to do not like inspection, I should see everything but break inspection show up, right? So that could be extremely useful in a certain situation. I can use like similar to the equals operator if I want. If I want to use an underscore that matches a single pattern, a percent sign matches any sequence of characters. So we can see here, there's a lot of different ways to use like effectively. Um, you can be combining it with the lowercase operator so that you can write queries where you don't have to worry about case sensitivity. And yeah, similar to, I don't want to talk about Postgres, I do want to briefly talk about. Um, I'm not sure where they put it in the Postgres docs, but the nice thing about iLike is it will be case insensitive, which can make life even easier. And so now if I run this query, we get break inspection. So iLike is definitely your friend here. That's really the main thing I wanted to show with iLike and like. I just want to see if folks have any questions around those before we move on. Okay, let me show one more filtering operation and then we will take a break. And that last one is the extremely useful in operator. And here the examples are pretty straightforward. Let's build out a couple of these. Let's just do maybe select star from car where ID in. And note that I'm giving this, I'm not sure if it's a list. I would actually have to look up exactly what Postgres calls this, but it's effectively a list or maybe a set. My guess is it's a set, that it doesn't offer unique values. but I can do this with other things as well. Right? So in is extremely useful, especially for string properties, or if I want to do this for, say, years. Maybe I want cars in these specific years, where I can find that as well. All right. Any questions around in or any of these filtering things before we take a break? Okay, awesome. Um, I know some of you guys have seen some of this stuff before. Some of it might be new, but the goal is really just kind of like walk through these features and build it up, and we'll build progressively more complex queries. Why don't we take 10, and then when we come back, we'll start to see some additions that we can add to queries, and we'll start to see grouping and some things like that. Thank you very much, everyone, and I'll see you all in 10 minutes. All right. So we've seen a lot of nice things we can do. The lowercase function, the inequality, the where clause to filter. We'll talk about order in a second. Let's talk about limit. So I can have an SQL query to run, and it gives us 5 cars as a result. Maybe I'm only interested in getting 3 cars back. Now, on the face of it, this isn't necessarily useful. Maybe I want the 3 oldest cars. And I believe the limit needs to be the last part of the clause. Oh, I apologize. What I need is I need to say order by and then the column that we're ordering by. And now we have, so in descending order, we're getting the 3 newest cars, but ascending from the smallest to highest value will give us the 3 oldest cars. So if we look at our, say, employee table, if I wanted to get my highest paid employee, and what department they belong to, my query is going to look something like this. From employees, order by salary descending, limit 1. And this should give me Jane Smith, right, who's got the highest salary out of the group and works in department 2. So really order by and limit, you're going to want to combine together, right? What are the 3 oldest cars on the lot if we're a car dealership? Information like that. And I just want to see if folks have any questions around order by and limit. Okay, cool. And I think those are also relatively straightforward. So let's take a look, and you can see a couple of other examples here, but they're all really what we've seen. Let's talk about group by. Group by is really interesting. It will bundle up rows into groups. Let me go ahead and just comment our last query out. And to show this, let me construct this query in chunks. And this is a good habit to get into, is when you need to figure out how to design a query, do it in pieces. Start with a simple query to get more than you need, and then filter it down step by step. So let me say that again. When you're designing a query, start with something simple and filter it down step by step. So in this case, let's say what I want to get is I want to get count of how many cars of each color. So to break this down, first I'm going to get the cars. And then we're going to group by color, and we're going to add in the count. Now these two kind of have to go together, but we're going to see this query built up in pieces. So let's select everything from car. Now let's use this awesome group by clause. And now we get a really interesting error. So this is a real common gotcha with group by. What group by does is it will combine all of our result rows into groups. So there's going to be like, when I say group by color, there will be one column, one row, excuse me, for blue, one row for red, one row for white, one row for silver, and so on. But this is what Postgres calls an aggregate function. Let's see if I want to get the rest of that message. There we go. So right now, Postgres is freaking out. It's like, how do I group these rows together? What the heck do I do? So this is not very interesting. I have all the different colors, and I'm grouping by color. There's only 8 rows. Note that we don't see blue twice. If I had just done select color from car, we see blue here and blue here because there's 2 blue cars. Group by is aggregating these rows. But now if I say do make with our group by clause, we also get an error. And it says this column must appear in the group by clause itself or be used in an aggregate function. And count is an aggregate function. You can combine stuff in a group by. This isn't very interesting because in our data, these are all unique combinations. But if I had like 5 blue Toyotas, I would see that here. And so, in fact, let's simplify this a bit. And let's use one of these aggregate functions that I keep seeing coming up. Let's look at the car ID. And so this is an aggregate function. So now Postgres will group all the rows and count how many rows are in each group. And now we get something interesting. So I just want to pause and check in and see if folks have questions here about group by. Are folks feeling pretty good about this? Cool. And again, I just want to point out this error. The column must appear in the group by or be in an aggregate function. This is by far the biggest gotcha with group by is I forget, oh, I want to look at the make too, but then I run my query and Postgres freaks out because it doesn't know how to group up make. So I have two options here. I either have to aggregate make somehow. It doesn't have to be count. It could be average. Average is kind of meaningless for make, but if we were dealing with, say, like average year, we could say as average year of car for color, right? An extremely long but very descriptive name. And in fact, let's do a little refactoring here to make this a bit more readable, as you may want to do as your queries get bigger. Undoubtedly, there's a way to reduce average precision. And it's probably just passing in, indeed, maybe we have to use round with average. Let's see if the AI can tell us here. Indeed, it wants us to use round with average. So again, if I'm building a report for a stakeholder, let's round this to, I don't care about the decimal places at all. So let's try it like that. And now that's much more readable, right? So again, like simple, but a real world concern. Um, again, you could have multiple group buys. If I wanted to break this down by like make, we would see this group by color and make. And let's in fact add make here. This won't be very interesting because it will all be unique. But here, if I like had like 20 white Hondas, I could see their average age and the number of cars, which if I'm a car dealer would make a lot of sense, right? That might be useful. So I just want to pause and see if folks have any questions here around this group by stuff. Cool. So what's also very cool is, and let's just get rid of this because I've kind of built this up. As this example here implies, we can create our own categories. And let's actually do this with drivers. And we can see here where SQL really is a language, the same way like Python or JavaScript is. It's just a much more domain specific one. So I, in fact, can create a case clause, basically an if statement in my query. And get drivers grouped by age range. These queries can be a little tricky to construct because everything is so intermingled. You can't really like filter it. Like you can't break it up into little steps. I do recommend just start with something really simple just to make sure that the query works, that I don't have any typos. And now I would pseudocode this out. I need to write my case statement. I need to get the count, and I need to group by. So I know I want to group them by this age group that I'm going to make up. So I think I'll do case when age less than 30. And I use the then keyword here instead of as to create our age groups. And really, if I'm going to kind of indent everything else correctly, it would look like this. And note that this when clause gets executed first. So here on line 63, we are already dealing with people older than 30 because everyone under 30 has already been handled by this clause on line 62. You guys see what I'm saying? Cool. And then we can add an else clause. And these will be the senior citizens. And then we can end our case statement. And here's where we would give it a name. Right? So this is the case. So if you want to, you could imagine all of this as being wrapped in parentheses. And in fact, you could add parentheses here, and I don't think it would impact the query. It should run just fine. And so we're going to give this a name. Let's call it driver. Oh,
Age group.
age group. I'm so sorry. I'm getting confused. I was looking at the wrong part of my guide code. And in fact, we'll just put this here. I think it shouldn't break the query, but it makes it more readable. And now let's count. I can count IDs, or I could just count the entire row. And we'll alias this to driver count. And we have these parts that we know should be good. And let's run this, and with a little luck, we will get all of our drivers grouped into ages. And indeed, we see here that we now have our drivers grouped into ages with nice names for these sort of result columns. And so, I've been mentioning how a query result is sort of a temporary table that's created. You guys can sort of see how Postgres might be doing that under the hood here. So I just want to pause and see what questions folks have or stuff you might be curious about. Andy,
What's
yes, sir.
I guess my question is, and what's the big picture for all the queries that we're learning? All those I like learning it and being able to display specific based on specific conditions, but how is it tied to the bigger picture?
Yeah, that's a great question. So there's two parts to that answer. One part is when we get to Django, you guys will not be writing SQL. You will be creating Django models using a Django model class, but those models will have fields that will be characters or integers or booleans. And Django will actually be generating the SQL to create tables and do queries and stuff. And then, in fact, in Python code, you construct queries using Django models in an object-oriented way. However, under the hood, it's generating and running SQL. And there's this idea of so there's this term abstraction in computing, right? Where it's like, if I need to calculate the average of 100 numbers. If I have an average function, I can just feed in those numbers and get my result, and I don't have to think about how that arithmetic is done, right? A really good abstraction means you don't have to think about how the black box works. You can just use it like a black box. There's also this term in computing, leaky abstraction, which is when the abstraction isn't quite as good as we hoped. And as you guys have all encountered, frankly, most stuff is sort of a leaky abstraction. And with Django, it's going to be like that. There are going to be times where even though you're writing Python code that generates SQL, where you're going to have to use pSQL to look at data. And so similarly, to really be comfortable and understand how to use Django models and stuff to talk to our Postgres database, we have to be comfortable enough knowing how SQL is working under the hood. So we have that mental model. So that's sort of the part one answer to your question. And the part two answer for the big picture is as you go into your career, you might be working somewhere like I've used languages like Python, but we just wrote the SQL queries in SQL and then had some function call my query because the more you use SQL, the easier it is. And these are really good abstractions, right? It does a really good job at what it's doing. So depending on the company you're working at, you might be writing SQL. And maybe we work for an insurance company, and maybe I'm writing some Python code to do stuff, but I need to get, an array of like all the people with car insurance who fall into different age groups, and I need to write an SQL query that my Python code calls to get that data from the database.
Yeah, that makes sense. Especially the second part, because I understand you can write functions and whatnot in SQL. So you do you have the ability to call those onto those things outside of SQL?
You do. They're also called stored procedures. If we're at a really big company, like if we were at an insurance company, they might do that. But to go back to our tail draw diagram from the other day, that I saw the comment that this looks like a Pokeball. Not intentional, but I very much appreciate it. And the idea of layers of code. Sometimes it's easier to write this SQL code as like text and just put it in a Python file. Or you have an SQL file that your Python code executes because again, the lower level stuff is, the harder it can be to change. So having this stuff live like in this middle level, say, or depending on the query, this outer level can make it easier to change code and work with it. And that would just really depend on sort of the architecture and the decisions that engineering team made.
Okay, thank you.
Yeah, great question. Great question. Um, and people do absolutely do that, where you can like save all this in the database. That was sort of the original vision. And again, if we were like a massive accounting firm, I think that's when you start to see stuff like that. But a lot of the times it turns out it's just easier to have it be in code. And Nick, I think you had a question as well.
It was answered.
Awesome. Yeah. Yeah. And again, like it really depends on the job. You may or may not do this, but SQL is so useful and it's everywhere. There are analyst roles where like depending on what you're doing, all people do all day might be writing SQL queries for reports. Um, that might not be, the software engineering gig we're aiming for. But like my first professional job was my job title was programmer analyst, and I did a bunch of that stuff. So it's also just like a good tool to have in the toolbox. Why don't we take a 5 minute break and then we'll dive into joins. Sound good? All right, gentlemen, thank you very much, and I'll see you all in 5 minutes. All right. Now, before we get into joins, I do want to point out uh, a nice add-on that we can do to this more advanced query and an interesting thing when we analyze it. So the add-on is simply we can add an order by driver count descending. And now if I run my query, I get the age group ordered by driver count descending. And if I wanted to do limit one, and if I remembered to save my file and then run it, I would get this is a query that now gives me the biggest group of drivers that I have. Right. And I don't know about you guys, but I actually am really excited about this because we look at all this stuff and building all this up, but what this means is I can get some really useful data out of my data set. Right. And so a business stakeholder might say, or imagine like we're Amazon and we want to know like who are our customers? Like what age group is buying the most stuff? Or what age group is, watching the most on Prime Video so we can create new content for them. And that's a really simple example, but someone on the data science team has to go and answer that. And to do that, you need to know how to query the database to be able to get that kind of useful information out of it. The other thing I want to point out is, and let me just comment out this limit. If we use explain analyze on this and run it, let's look briefly at the explainer here. We see a couple interesting things happening. We see there's this sort key argument. We see, in fact, it's telling us the sorting algorithm that it uses, quicksort, which I think is in fact that same algorithm that Python uses to sort. If you poke around on the internet, oh no, they use Tim sort. We're going to learn about merge sort. Quick sort is a bit more advanced than merge sort. Um, have you guys covered divide and conquer algorithms with your TAs and binary search and stuff like that? Have you guys looked at merge sort? Okay, well, we've got merge sort coming up. It's a divide and conquer sorting algorithm. And then quick sort, we don't currently cover in the course, just because it's a little more advanced than because of time. But you can see it here. You can actually write a quick sort implementation. And a common question is like, what's the point of data structures and algorithms? And we're not going to build Postgres, right? Maybe you guys will go on to build a database engine later in your careers or something similar. But we can see here that, when Postgres was created, they had to decide what sorting algorithm do we use. And they're using quicksort. So I think that's really cool. We can see how much memory the quicksort sort takes up. We can see some hashing information. We see how Postgres thinks about the grouping, the memory used for the grouping. And then what I want to point out here is the planning time for this query has gone up to a tenth of a second, about 13 milliseconds, and the execution time has gone up too. Most of our previous queries took, I feel like 0.05 or 0.06 milliseconds. This one takes twice as much, right? Which might not seem that long. We're talking a tenth of a second. But let's imagine this is some big database for Amazon, and let's imagine the database is getting like thousands of queries, different kind of queries per minute from all sorts of different users or applications using it to execute. So this is like if we were on a back-end engineering team or platform engineering team, or maybe a database administrator, these are the kinds of things where when you're dealing with real world data at scale, you have to start caring about. For like our personal projects, there's kind of over optimization, right? But I just want to point this out so to see this stuff because I think it's cool to see like real world performance data, even if it's relatively lightweight. And this is not a lot of data, right? We only have like 10 rows here. So I'm actually kind of shocked it took this long to do this. So this is a pretty demanding query. Um, I've heard a lot of war stories of software engineers, buddies of mine, who like joined a company and there was some query that took like a really long time that had just sat there for years and just no one had, someone had done a bad job of writing it in the first place and it just sat there and they were able to reduce it like by like seconds or something like that. So performance does end up cropping up in the real world. All right, that's my little segue. Let's talk about joins because joins are cool. So joins is how we connect tables together. And let me comment this out so we don't see it. Joins are how we connect tables together. And the simplest version of a join might look like this. Select star from car, join driver on car.driver equals driver.id. And this is a lot of data, right? I'm saying get the car table, connect it to the driver table, and match where the driver ID matches the ID for the car. And so now I can see all of my cars and their drivers. Now, I don't necessarily need all this data. I might just want the car's make and model, and then the driver's name and their phone and email. Carlos, I think you reminded me the other day, um, I don't need to prepend each of these with the table that it comes from to namespace it. That said, as I'm looking at this, I might get confused as to which columns these come from, so it certainly can't hurt if I want to.
You would only need to do that if the names weren't unique, right?
That's correct. If the names weren't unique, I would need to do this. Um, when the column names are unique, I can totally do this. But maybe I want car.id. And in fact, let's throw an ID here and we can see this fail. And we see here this error column references ID is ambiguous because we have car.id and driver.id. So let's do car.id and let's also give it an alias so that when I'm looking at this, I know what the heck ID it is. So this is a join, right? And now it might start to get a little more interesting. I wish we had like duplicate makes to sort of group stuff by. Maybe I just want to order by name ascending just to make my query a little more useful. Um, I would just want to check in and see if folks have any questions around join here and this basic concept of joining. Okay, cool. Now, there are different kinds of joins, and there's this one diagram. I grabbed it from here. I have a couple links that I'll share. But this is sort of the one diagram that everybody looks at for joins. Um, Let me grab my pointer. So this diagram here, this is what we call an inner join. And this is, I believe, sort of like the default join that happens, where we want the overlap between what's in table A and what's in table B. And you see these Venn diagrams because the idea of join comes from the mathematical idea of, I believe it's like sets. Um, but maybe there's a situation where I want to know the stuff that's only in table A that doesn't overlap with table B. And we would call this a left join. I think even technically a left outer join. I might want a situation where I get everything in table A and the parts of table B that overlap, and this would be a left join. A right join would be I want table B and the parts of table A that overlap. Or maybe I want parts of table A and B that don't overlap at all. So let's look at why these different kinds of joins might be useful. And let me construct a couple as we go here. So let's start by just looking at our services, our car service table, our join table. And just to kind of remind myself, let's look at it. And this is where we have one column that's the service ID and another column that's the car ID. And so I've got services, I've got cars, and to go back to the join diagram, right, if we're going to end up with car over here, and then service over here, in the middle, we're going to sort of use our car service table. So maybe I want to see all the cars that have been serviced. So maybe actually I want to do select star from car, join car service on car.id equals car service car ID. And in fact, maybe I want to see the car's make and model, and maybe I want to see the car ID. And maybe I want to see service ID to see what kind of service it got. And this is coming from the service table. So let's just type this as car service just to make it easier. And in fact, let's put all these joins now that this is starting to grow. Let's put them like this. And I think this can be a really useful way to lay out your queries to sort of help logically organize them as they get more complex. And now I see all the cars that have service. I, in fact, see some repeats. Right here, the Jeep Wrangler, it got two different services, right? It got service number 3 and it got service number 1. Now, it looks like, in fact, all of our cars have service. Let me insert some cars into our service table or into our car table. Insert, and I actually need to remind myself briefly. Insert into. Okay, perfect. Insert into car, and we're going to do make, model, year, color. And let's look real quick at the car table. Make, model, year, color. Driver, I'm not even going to worry about. We're not going to give it a driver. And we're going to do like a 2025. We're going to do a Honda Civic from 2025, and it's going to be yellow. And we're going to actually insert like 3 of these things. And in fact, now that I've written this out, I'm just going to paste and run this in pSQL. Let's see here. Key ID1 already exists. Interesting. It's going to force me to add the ID. That's fine. We'll just kind of fake it for now, and I'm not going to worry about it. But this is that sort of sequence issue where I need to update the ID sequence. And this is annoying, but we'll do it very quickly. I just want to get a couple cars in here. And I'll leave this here as reference for folks. But I'll comment it out so it doesn't run all the time. So, but what I've accomplished now is we've got some cars, they don't have a driver, they haven't been serviced. So if I run this join query, I don't see my yellow Honda Civics because by default, when we use that join keyword, it's doing this inner join. Right? By default, a join is an inner join. Let's see what happens when I insert left join instead of inner join. Now we see, and let's add the color just to aid in identification of our rogue yellow Honda Civics. We see our yellow Honda Civics, right? Because left join says, don't just get the parts of tables A and B that overlap. Give me everything on the left table. So give me everything from car, plus give me the data from the car service table. So really, I should update this diagram a little bit. Let's get rid of service. Let's move car service over here. Right, give me everything in the car table on the left And then if there's no data in car service, just leave it blank. So I just want to check in and see how folks are feeling about this left join concept here. Alex, yes, sir.
So would this look much different if you're joining more than two tables together, or is there like a separate rule of thumb for that kind of thing?
Um, you mean, can you maybe specify a little bit?
Like say you have a table that has an employee and then their basic information, and then you have the social security table, and then you have a third table that houses
Yeah,
just like their address or something, and then you want to put all of that information on one table. And are there is there like an easy chart like this that you can just point to just for more than two cases, or do we kind of just have to work through it?
got it. It's the same thing with more than two cases. Let's in fact add in, let me show you guys one more thing, and then we'll add in multiple joins and we'll see that in action. Sound good? Okay, awesome. The one thing I want to point out is once you start using like left join or right join, then the order which you declare what table the from and the join on matters. Like when I execute this right join, we don't see our yellow Honda Civics because the right join has started over here from car service and moved left to car. And let me pull up my other favorite database design tool. And we're just going to do car ID and service ID. And we're going to do ID, make, and model. And color. And I'm not going to fill out too much here because I don't want to get too lost in the sauce. But let's just do like 1, 2, 3, 4, 5. Ford, Honda, Ford. These aren't going to correspond to real values. I apologize. Um, what I really just want is just some of these just so I can draw some boxes. So with the right join, we start with car service. And then we grab the matches. So this is, I apologize, this is probably not the best diagram. In fact, I think we're probably better off with the Venn diagram. Um, but do you guys see what I'm saying here? Like, if I change this to left join and we make this from car service and we do left join car, we're not going to see the yellow Honda Civics. right? Because our left side is the car service table, and then we're only grabbing the matches from car. If I flip this to right join, we will see the yellow Honda Civics because we start on the right side, which is car, and we grab everything, and then we grab the car service matches. And we see, in fact, our yellow Honda Civics down here. So I just want to check in and see if folks have questions around that and if that sort of makes sense. And similarly, if we did from car, right join, car service, and we make this maybe, does it let me do a left outer join? Um, sorry, let's do um yeah, I'm not gonna worry about I'm not gonna worry about the inner and outer joins because I think I'll get a little lost in the sauce describing the outer join stuff too much. Let's go on and let's add in another join, and then we can kind of see the impact of left and right join on how that works. So plain old join is an inner join, and if I run this query, we see all the cars that were serviced. Um, we don't see those yellow Honda Civics. Let's do another join on services on car service ID equals services dot ID. And then let's over here add services dot name. And let's see here. Column car dot service does not exist. I have a couple typos here. Forgive me. Let's try it now. Column services dot name does not exist. And that's because it's not name, it is name of service. There we go. So my 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 spreadsheet is not doing that great here, but we have, car, and I'm gonna go ahead and put the ID over here, and we'll just say like make, and we have car service, and let's say like car ID, and we have service ID, and then we have service, and we have ID, and we have name of service. And what we've gone ahead and done is with these two joins, we do a linking here, right? And then we do a linking here. And so that's how we link all these tables together. And in fact, if we use explain, analyze, we should see something interesting. And we see here a join, a join, a join. We're not in fact doing any filtering. So there's no filtering that happens there. But from linking all these tables, we then just return the columns that we care about from the result rows. So I just want to check in here and see how folks are feeling about this join with two joins working together, because this is a really, really common pattern. So this is a critical thing to be comfortable with. Cool. Um, we can start to do like really interesting things with these joins. I'll show a join and a group by in a minute. But first, let's go back to the question about, when I'm dealing with multiple joins, how does left join and right join impact stuff? So right now, we don't see the yellow Honda Civics, right? Because if I'm going to draw some circles here, let's I'll I'll use squares. So I think maybe that's a little more actually intuitive since tables aren't circular. And let's have like this can be car service. And then we'll have red for service. So we've got cars and we've got car service. And then we have the list of services. Now we know there's a couple more cars than were serviced. Specifically those yellow Honda Civics that I created. I think there were three of them. Right, and here's all the other cars. I'll just kind of, I'm not going to fill them all in, but just as an example. Um, and then for car service, because the job of this table, is to represent when a car is serviced, there's not really any possible extras. In fact, let's fill this out. We'll have 3, 4. It's not going to be exact. We'll just have 5 of them just in the interest of time. And in fact, let's go ahead. Let me kind of scoot the services table over here a bit so we have a little more room. And if I look at all the different services, there's oil change, there's brake expansion, there's engine tune-up. Let's add a new service. What service should we add? How
Uh,
about replace brake pads? And I don't know, this one's gonna be more expensive. And so now I have a service that no one has used, right? So if I'm going to update my diagram, over here, I've got replace brake pads. And now that we have this diagram, let's play around with these joins and see how using left versus right join for different things impacts things. So right now, the way we're currently doing this, by using this inner join from car to service, we get this part, right? We do an inner join here and then an inner join here. Let's change this. Let's do a left join here and keep that second join an inner join and see what that looks like. And let me give myself some more real estate here. So interestingly, it doesn't look all that different. And the reason is, while this first left join would have grabbed these yellow Honda Civics, the second join, which is an inner join, filtered them out. Right? The first join basically produced a result table that was all this stuff. But then that got filtered out in our second join, which is an inner join. So what happens if we change this second one to a left join as well? Well, now we see those yellow Honda Civics and they don't have a service. Right? Because our first join here, this left join did its job. It grabbed everything in the car table and the stuff from the car service table that overlapped. And then our second join was still a left join. So it grabbed whatever in the services table overlapped. But obviously these yellow Civics, they weren't serviced, so they don't have a related service, and we just see empty values. And I just want to check in and see what questions folks have here and if this makes sense to people. Cool. Now, as you can probably tell, the inner join, often just if someone says join, they mean inner join. That's like our bread and butter that we use like 90% of the time. But sometimes it might be useful to use a join with a left join or a right join to get information about stuff. Also, for instance, if I did here right join car service, that's in effect going to shrink this down, right? Because car service only has serviced cars. So if we run this query, no yellow Honda Civics, right? And this left join doesn't really do anything because there's nothing extra to grab. It might as well just be an inner join. And in fact, this right join on a join table might as well just be an inner join. If I change this to right join on services, which would include replacing brake pads, let's see what happens. And it's a little hard to see, but you guys see how all the way down here, it says replace brake pads. So that wasn't there a minute ago. And that's an effect of the right join. Now, it's a little confusing, I think, to kind of think about the right join stuff. It's kind of easier to think about stuff from a left join perspective. Let's construct another query. And with this query, what I want to do is see a count of how many services were used for each service. So to do this, first I'm going to want to get all the services. And then I'm going to want to join on car service. And I'm going to want to group by name of service and do some sort of count on car service dot ID. Right? Because I want to see like how many people got a brake replacement. So let's just start with select star from services. Let's make sure I have this working right. So far, so good. I'm not going to worry about the group by. And here's a really good coding workflow technique for this stuff. Get your joins working first and then worry about the other stuff. And in fact, let me just gonna put that there. And let's say join car service on services.id equals car service dot service ID. It's just easier for me to write out the table names. It's a bit closer to how I think about the problem. And I see that that join's working. Great. Let me maybe get rid of some stuff that I don't care about. I really only care about name of service. And I think I want to know, let's just keep service ID there just to see it. And yeah, let's see price. Why not? And then I want to see car service.id as, let's call this car service ID. And let's see what this query looks like. And I have a typo. And let's see here, error syntax, error at or near here. So let's go ahead and fix this. I'm just gonna have this out to see where my error is. I probably don't need the
Service should be pluralized or the opposite. So on line 99, you have
Oh yeah,
service.id, and then on 103, you have services.
thank you. Yeah, and this is why with your table names, stick with singular or plural. There we go. Thank you so much, Nick. And I think the single quotes I had were also causing an issue. So this is a little more useful, right? And in fact, let's just I don't even really need the service ID. Though it is useful. Let's just call this as service ID. I think the single quotes work. Let's find out. No, it does not like the single quotes. So now that I have my tables hooked up, now let's do the group by and the count. So let's start with group by name of service. I'm going to get rid of service ID. I'm going to get rid of price because it's not going to know how to deal with the aggregate. And I don't want this anymore. Let me in fact leave this here for you guys as a reference and comment it out. So we want name of service, and then let's just do count car service ID as I don't know what to call this, amounts, like,
Number of services.
yeah, number, let's just call it purchases. Let's call it purchases of service. I'm sure there's a better term. I just don't want to get like too confused in my own head. And I think this will do it for us. Let's see if this does the trick. And so now we have a nice group by combined with a join, and I can see the number of services and some useful information. I could, in fact, join on the car table. There's nothing stopping me from doing another join. Oh, and what I wanted to point out here was if we change this to a left join, notice how we don't see replacing the brake pads here, right? And if I'm getting data on like how my car shop is doing, I want to know what people aren't buying as well as what people are buying, right? So this is a really good example of a use case for left join. And let's in fact order by purchase of service. Let's do descending order. And
Purchases.
yeah, thank you so much. Yep. Again, it's always the pluralization. And so now we have this in order. I'm trying to think of like if there's anything interesting that we could add with cars. Maybe we want to do something like join car on car service car ID equals car.id. And we want to say maybe like average car.year as average car year. We could see like, do the older cars need a certain service more or something like that? And let's round that to 0 points of precision. So just to kind of make up a reason to throw another join in here that's sort of sensible, I just wanted to show that as well. So this has really covered most of the ground that we wanted to look at for joins. We've gone through left joins, we've gone through right joins. The curriculum for today has a number of join examples that builds up more slowly too, which I think could be useful to walk through. We've seen joining 2 tables. We've actually seen joining 3 tables with car. So this is like the classic join scenario, which I believe we did. I believe we did it. But where I want to get information about cars, their drivers, and their services. And here we see we link car to driver, then we link the car service to the car, and we use that to get the service that the car does. Right, so there's a couple of other useful examples here. I would recommend looking through these links. These go to the docs, but these are going to be useful ones to go to. I'll also share, there's a couple good articles on joins. And I'll share those as well. And of course, I'll share this with this diagram, which I think is awesome. And that really covers everything that we wanted to hit today. So I just want to see if folks have questions about joins, or if there's particular scenarios you want to see, or if there's anything you guys want to code up as a group while we're doing this, like if we want to write some queries. What's on people's minds? How are we feeling? How are we feeling about joins?
Um, we'll know when I try 'em.
Good deal. I was trying to come up with like some sort of join related scale to ask how people were feeling, but I couldn't come up with anything good. Let's take a quick look at the assignments and then we can actually wrap up. So yeah, this one is really just import the schema file into draw SQL. Remember that in this example directory, there's all the SQL you need to build the car shop that we've been working with in the lesson today, and all the CSV data is there as well. So just experiment with like importing that into draw SQL just to get a feel on it. And then for the game store, there's a number of query challenges we'd like you to write. I do recommend putting all of your queries in an SQL file like you've seen me doing. I think it makes life a lot easier. If you want to, you could even maybe make separate queries files to start with. So as you can see, there's going to be things like employees making 40 grand a year. You're going to need to do maybe a little bit of regex, stuff like that. And then for 32 flavors, you will also have to write some queries now, which also does mean I believe you may have had to generate some fake data for this one. So in fact, yeah, I would like you guys to work with ChatGPT to generate fake data. And this is actually a great prompt engineering exercise because you can give it a whole SQL file. Like, let's just grab all this. Now, you probably want to be a little more precise than this in your prompting, but here is an SQL schema. Generate another SQL file called data insert.sql that has insert statements. Generate fake data for each table. Make sure to respect table relationships. And we're going to give ChatGPT a minute. You may have to improve on this prompt a bit, as I said, but I just want to sort of capture the idea. We'll let it do its thing. But so your task here is to, with the help of AI and by hook or by crook, generate some fake data. At least 3 different stores, at least 3 different employees, at least a couple sheet entries in inventory, and at least 1 customer making a purchase, and then write some SQL queries. And then for 64 slices, since this one comes with CSV data already, we would like a number of queries, right? And this is where the queries start to get interesting. You'll have to do some on average and aggregate things. So the assessment is definitely going to have you working with CSV data and group and aggregate queries. So I would recommend start with the game store assignment and do those queries, then go to 64 slices and do those queries, and then circle back to 32 flavors. And if we head over to ChatGPT, we can in fact see it's generated employee data, it's generated names, it's added departments for them, it's given a preview. Let's just say display it here. This is Well, it's doing a crappy job of rendering it, but we should be able to download. Just print out data, insert SQL for me to read like a normal file. There we go. And now we can copy this whole thing. Now, it has no idea that this is a car shop, and to a degree, who cares? Like, look at these some of the things that it made up. You clearly can improve this prompt, considering that I spent about 10 seconds and 2 sentences doing this. Though I have some practice with this. This is actually how I generated the fake data for 64 slices. Was I told it to use a Harry Potter theme and come up with like pizza toppings and store names and employee names. So I think this is really good practice because this is a nice sweet spot between, not using AI at all and starting to get a sense of how you can use it to like enhance your coding productivity without hurting your learning process. So that's really the goal here with this and to practice a little prompt engineering. So do folks have any questions about the assignments for today? Okay. Awesome. Gentlemen, thank you very much. Let me go ahead and stop our